Today we'll be covering Chapter 20, which is Analyzing TCP, Chapter 22, which is Analyzing DHCP. Now Chapter 21 in here, I know it's if we go in order we should be covering that, but because it's more of a like, okay, here's a graph, it's not really looking into headers or anything like that, we're going to save that for tomorrow. I'm going to put the 1Z, 2Z type stuff later on, right? Because analyzing TCP, knowing the sequence and the SYN-ACK and all that, that's very important. And also DHCP is very, very important. Not just from a networking perspective, but also from, you could get one of these questions in a job interview. So we'll talk about that later on. Chapter 20 is Analyzing TCP. We're going to have some practical stuff in a couple minutes, but let's just talk about the header right here. You can see a pretty big header. This image is courtesy of Nmap. We've got 20 bytes. We've got a source port and destination port. Now remember from yesterday, the IP addressing was taken care of by the IP header, so we don't need to duplicate our efforts there. So source port, destination port. We have sequence numbers and acknowledgement numbers. We'll talk about how those come into play when we start sending large amounts of traffic. Because what happens for a lot of people is in CCNA or also Network Plus, you generally remember the three-way handshake, just rote memory, SYN, SYN-ACK, ACK. Hopefully you guys know that. And that's kind of where everything stops after that. You can't really explain, okay, well, what exactly happens with SYN, SYN-ACK, and ACK. You just kind of remember those three things just by rote memory. So we'll get into that. We'll be looking at packets, see exactly what's going on. We've got some offsets, some flags, and of course we have a checksum. Always have a checksum. So urgent pointer. You won't run into this very often, and some options here, right? Okay, so we need some way of setting up a connection. TCP is connection oriented, so we need to have both sides kind of talking on the same page. Like, okay, I'm talking to you, we're ready to send, let's agree on how much to send, let's agree on, okay, I received the information, that type of stuff. If we were UDP, we would just shoot the data out and hit the other guy and not care what he thinks. But with TCP, we actually want to say, okay, let's sit down, let's shake hands, let's have a conversation, and then start talking. Right? So it's a little, actually not a little, but a lot more orderly. We also have something with, if data gets lost, we need to have some type of way of recovering the data. And for that, we need to know if data is actually missing. And you can imagine this as, the best way I know how to explain this is, we're going to do a little history here. So way back in World War I, you got the two sides here. They dug trenches. And, whoops, lost it. So we had the Allies on one side and we had the Germans on the other side fighting and stuff. All right. So let's say you got two bases. You got a base over here and a base over here. In between, there's lots of evil stuff. Landmines, bad people, Germans, sauerkraut, whatever, right? There's bad stuff in the middle. And yet you need to send lots of information confidentially from one side, and you need to make sure it gets to the other side. Could be books, could be a whole bunch of books, could be whatever you can imagine, maps, whatever, right? So let's think about this. Not even thinking about networking, but thinking about how you would do it. You would need some way of telling the other side that data is coming. You're not going to just chuck a book over there because the other side might go, well, okay, did it really come from my buddies or did someone else, is someone trolling us? You also need to tell the other side how much data you're sending, okay? So if you chuck a book over to the other side that's 1,000 pages long, how does the other side know that pages are missing, or maybe possibly even worse, pages have been added, right? We need to make sure that if we send a book over, that's 1,000 pages, 100 pages, whatever it is, that the same number of pages need to make it to the other side. And then also in reverse, going from left to right and right to left. So we need to think about these things. We also need to think of a way to stop the conversation so that both sides know that, okay, we have no more data to send. So, that's it, right? So whenever you're looking at complicated stuff in networking or whatever, just break it down into something that you can relate to, and it'll make things a lot easier. Because sometimes like all these words and terminology, they can really mess you up. So the SYN, ACK, and ACK three-way handshake, all that is setting up the connection and making sure that both sides are ready to send data. That's all it is. So one side says, okay, SYN is like you offer your hand out, you put out your hand. The other side also puts out their hand, and you can imagine the ACK as you accepting and actually grasping his hand and doing the shake, right? Because just because you put out your hand at a party doesn't necessarily mean the other guy is going to put out his hand. And, the guy doesn't like you, whatever, he could slap you in the face, punch you in the nose or whatever, right? So SYN, you put out your hand, SYN ACK, the other guy puts out his hand, and the ACK is actually where you clasp and shake hands. So that's the actual act of shaking hands, and now you agree to talk, exchange business cards or whatever. That's the American way. Of course, in Asia, you do the whole bowing thing and all that complicated crap, but we won't talk about that. The graceful session termination, kind of the same thing. Takes, we have a fin wait, fin ACK. Fin you could basically think of as finish. And it's kind of interesting. Fin doesn't mean, doesn't tell the other side to stop. Okay, that's a common misconception, is that if I send a fin over to the other side, I'm telling the other side to stop. It's not exactly what it means. It just means that your side has no more data. Fin means I'm done. So think of that, I'm done. Fin wait means the other side acknowledges, and then fin ACK is where you actually gracefully kill the connection. There's also something called a reset, and I didn't put that there. So a reset here is a forced killing of the connection. You just want to kill the connection outright. Reset is the one you would be looking for. And I think if you actually look in packets, you'll see it abbreviated as RST. Right? So let's take a look at some of this. We're going to take a look at Wireshark. We're going to start a connection to a web server or something. We'll figure it out. And then we'll take a look at the SYN, ACK, and ACK, and just kind of take a look at how it looks. And then we'll actually get into the whole sequence number stuff, right? I included another picture, made this, hopefully, yeah, it's correct. Made this last night. It looks complicated, but if you go through it step by step, which we will do, it will make a lot of good sense. So let's go into Wireshark. And as always, go to Capture Options. And in my case today, I'm actually on wireless. Should not be, but that's the way it's got to be. And uncheck all these ugly display options, uncheck all the resolve stuff. We want to make this as clean and fast as possible. And we'll click Start. And so you got some packets going. And open up your web browser and open up another tab. All right. Who has a favorite website they want to go to? Let's throw out a suggestion. Hopefully something I haven't been to before. Something clean. All right, let's do this. Goodreads. Okay, let's do Goodreads. How about that? Goodreads.com. Enter. Right. So Goodreads.com. We got a web page. Life is good. Then we close down the tab, and then stop the capture on Wireshark. And then we'll look at Wireshark. Okay, so because you had your video conference going, you're going to have a lot of packets. We need to filter this down a little bit. So we could filter down just by TCP. We type in TCP. That's going to be still quite a lot, right? Still quite a bit. So we need to kind of figure this one out. If we take a look here at filtering, I gave you a couple good filters. tcp.flags.syn double equals 1. Right, so let's try that. tcp.flags.syn double equals 1. So give me all the packets that have TCP syn in them. And this should, okay, nice. This should make everything a lot better. All right. So just like yesterday, source and destination, they're all numbers, gobbledygook. We need to change that. So we'll go back up here, upper left corner, view, so file, edit, view, and we'll turn on all of these name resolution things. It's enable for transport layer, it's good. Go to view, name resolution, enable for network layer, and also enable for use external name network name resolver. So that's DNS. All right. So here you go. This makes a lot more sense. And your Goodreads is probably going to be near the bottom somewhere. We have it filtered out, TCP syn, and that's probably the first one, so that's good. So we click on the one that's from your computer to www.goodreads.com. Now you notice, like many websites, after you hit that website, you started getting a whole bunch of crap from like CloudFront and Akamai. These are all CDNs. Double click, you got hit with ads. So it's just you got a barrage of stuff that you have. There are Chrome and Firefox plugins that will draw out a matrix or a map of all the websites that open up. It's kind of like a humongous spider web that come up after you visit every website. Pretty cool tools to look at when you're playing around with network stuff. All right, so we'll go to the details pane. This is in the middle here, and we're interested in expanding out TCP. So that section right there. So we click on this plus symbol to expand everything out. All right. All right. So what we got here is we're looking at TCP. We have a source port. We have a destination port going to port 80, so that's good. We have a sequence number of 0, acknowledgement of 000. So this means we're just starting off our conversation. This is our first time hitting the other guy, so everything's basically a 0. We got a checksum. We got some flags here, and this we know is syn. So if you expand out flags, boom, like that, we have 1 bit set for syn. Right there. And we got a window size, and urgent pointer is not set in there. We got some options in here. Nothing too crazy. Maximum segment size right there, 1260. All right. So that was our syn. Now coming back, you'll notice that if I click, you should have one that's 1 or 2 below that. It's coming back from Goodreads back to your PC. So this was the response. And if we expand out the flags, you should see 2 set. Syn, right? There. And ACK. Syn ACK. So syn, SYN-ACK, this is the response back. No data transferred yet, we're just talking right here. And you'll notice something interesting. If you scroll up a little bit and you look at the ACK, what happened? So when your computer talked to the other guy, it was sequence 0, ACK 0. When Goodreads is talking back to your computer, sequence is still 0, but ACK has now changed to 1. So, yep, it added a 1. Now when we see the zeros here, you can notice that it says relative sequence number. These numbers, if you look at the packet, are not actually 0. They're actually some big gargantuan number, and Wireshark sets it up to be 0. That way it's easy to remember, easy to digest. And you're thinking, okay, why do we do that? Well, let's go back to our World War I example where we're in the trenches. So you got 2 trenches here, both of you are good guys. You're trying to send information across, right? Trying to send a book or something across. And you are trying to agree to set up communication. You want to know that the other guy's a good guy and the guy you're sending to is a good guy. There's lots of bad stuff in the middle here. Just, landmines, things are blowing up, stuff like that. What would be the problem if we always started on the same number? If the guy on the left said, okay, if I shout out the number 100, let's start talking. We never change it. We always keep it at 100. What would happen? What could possibly happen with this scenario? If one guy says, okay, let's agree on if we send the number 100 to each other, we're good. Could be a spoof, yeah. Could be like there's some Germans in the middle. They hear this, and Germans speak English fairly well, and they could spoof it, right? So it could be a bad situation. So that's why the sequence numbers are kind of this random big humongous number. We shoot it across. The other side gets it, and let's say we shoot across a number like 3,248,000,000, like 248,123. All right. So rather than just repeat the number back, what we do is we take that number, and when we shoot it back, we add a 1. We increment it. And the reason for this is we now know that the other side is listening, he's cool with it, and because the number's been incremented by 1, we know that the other guy's actually thinking, he received it correctly. If instead, you got to think about it from a computer's perspective, if instead the same number was repeated back, we don't actually know if the other side received it. This could be noise. This could be just some random thing that came back. But if it's one more, you're like, oh, okay, well, he saw the number and he added 1, so must be good. Okay. Does that example make sense? I know the relative sequence number kind of gets some people, but if you just think of it from a security perspective, we always need to start a conversation with a random number. That way we can ensure that nothing's been spoofed and we're somewhat secure. Now from the Wireshark perspective, it's a 0 because it's a nice, easy number. Okay. All right, so SYN, ACK, and ACK. Let's see, we have a question. How can we actually see the initial sequence number in Wireshark? Okay, if you want to see the initial sequence number, here's what you do. We click on My Computer to Goodreads. You go down here to sequence number where it says it's a 0, but when you click on that, notice that this section down here, section down in the hex, is highlighted. So what you can do is you could do this. You take calculator, we go to hex, click on hex, put in those numbers 60, D6, 52, FA. This is, in my case, I click on decimal, and then that's the actual sequence number. Another way is you could change the preferences to say don't do relative sequence numbers. So it's pretty easy. Let's change our filter a little bit. tcp.flags.ac double equals 1. So basically I want to find the final ACK here. So we're scrolling down, we're looking at Goodreads. I think that might be it. ACK and push. Yep, that might be it. Okay. So eventually you're going to find your computer to Goodreads. You're filtering out for ACK. So here we have an ACK, so that's good. And then a push. And this is where we actually start our conversation. We've now agreed to send some data. So keep that up for a little bit. Let's go to our hackpad, go to the picture, and got a picture here. So let's talk this out. Your computer going to Goodreads, you sent out a SYN. Right? We saw that. We saw that it had a flag set, and we saw the sequence number, and the ACK is 0. Next, we saw that coming back from Goodreads was a packet that had bits on SYN and ACK. Two flags had one set. Sequence still says 0. And the ACK is now 1. So 1's been added. Okay. And then finally, in this section right here, we send the acknowledgement, sequence, and ACK is 1. These first 3 things right here, so these first transmissions, first 3, left to right, right to left, and then left to right, no data is being sent just yet. It's just a connection being started. Okay. After the connection has been started, that's when we actually get to the fun stuff of sending data right here. So it's basically saying, okay, we've agreed on our sequence numbers, we're all synchronized, and now I've got 500 bytes to send you. Right there. And get, push, whatever it is, it's basically saying, give me stuff. Here's some stuff. Now also give me stuff. Those 500 bytes hit the other side. And notice what happens here. Right here, the ACK changed to 501. It's basically saying, okay, I see that you sent me 500 bytes correctly. .500 good bytes came through. Now, if somewhere along the way half of that got killed, like 250 got killed, whatever, then the ACK coming back would be 251. It wouldn't actually be 501. It would be 251, or however many bytes that it got. And as you can imagine, when the response goes back, when Goodreads responds back to you saying, hey, I'm up to 251, the sender over here, the PC over here is going to say, oh, okay, I need to resend some stuff. Right? So these sequence numbers, these ACKs and the links, they are all basically keeping track of bytes. And if the numbers aren't matching up, then basically we know that something's been lost. And then TCP will know to retransmit the information. Okay. So let's see if we can take a look at that in our stuff here. Got a TCP segment length there, 442. Okay, so on mine, if you look, you'll see that I've got a TCP segment length of 442. And you can see the next sequence number jives up correctly, 443. It's one higher. Right? Acknowledgement number 1 right here. Anytime you see ones and zeros, you know that the other side has not sent anything. I'm not acknowledging anything. Or also it could be that maybe the other side did send something, but I didn't receive it. And if you click on the next one, you should see things start flipping. Let's see what we got here. Ooh, that's a big one. I sent a lot of data on that one. So sequence number 531,301. Acknowledgement, we're up there on the acknowledgement. So in between here, I sent a lot of data. And also what's happening here is Wireshark tends to hide some of this stuff. Doesn't account for everything. So as you click through this conversation, you'll see, let's see, let me go down here. Yeah, my sequence number. So that actually makes sense. Web pages are fairly big these days. Lots of pages, border, icons, all this stuff. Now my sequence number is it's up there and they're like 9.9 megs. It's getting up there. That's Fuse meeting. That's nothing. All right. Now this is interesting right here. Here we see Goodreads to me. If we look to the flags, it's an acknowledgement. So this is, we've kind of restarted a conversation. Maybe my computer started another connection to Goodreads, and now we're having another transfer. And 443, source port 80, okay, that's good. All right, so it's pretty fun stuff. Now you can click down here to sequence and ACK analysis. You should have a kind of expansion down there beyond the checksum. Let's take a look at that. And it'll give you a little bit more information. So this is an ACK to the segment in frame 67047. You can click on that and it'll bring you back, give you the round trip time and all that good stuff. Right. All right, so the first 3 lines, left to right, right to left, left to right, that's just the connection setup. And in plain English, when you see the data start transferring, it says, we're on our first packet, and I've got 500 bytes for you. That's basically what it translates to. On the second one, where sequence equals 1, ACK 501, length equals 2000, what that means is I acknowledge that you sent 500 bytes. I see the 500 bytes. And for my first transmission to you, I've got 200 bytes. And then on the third line, sequence 501, ACK 201, ACK, I acknowledge that you sent 200 bytes to me so far, and I'm sending you another 200 bytes starting with number 501. Okay, so the first couple times you look at it is kind of, might be a little bit complicated, but if you look through a couple Wireshark diagrams, do a couple packet captures, it gets pretty easy. Right? Questions about the SYN, SYN-ACK, and ACK, the TCP handshake, and also sequence and acknowledgement numbers. And if you want, there's a very good article out there, SYN, ACK, sequence numbers, packet life. Jeremy Stretch has a good article about that. There you go. And I'll paste it into the hackpad. Yep, there's that link in hackpad. Really good article. I think the graphics is there. And he breaks it down. One kind of funky point is that people get a little bit hung up on is this addition of the 1 right here. So here is ACK equals 0, ACK equals 1. You know, here's sequence equals 0, here's sequence equals 1. Yeah, that tends to trip people up. Technically, what the name for this is the phantom bit. The phantom bit. And it's we add that in just to let the other side know that we're listening and we know what's going on. Right? And you could Google for phantom bit as well. All right. Okay. So that is it. Well, there's a lot more in chapter 20. Obviously, read up on it. But the main thing is understanding the SYN, SYN-ACK, ACK, understanding how sessions are terminated, and also understanding the sequence numbers. Now, if we go back to Wireshark, for TCP flags ACK, there's SYN, there's push, there's reset. Let's see if there's any reset. tcp.flags.reset. Let's see what we got here. Oh, we have to do reset double equals 1. Ooh, look at that. Okay, so what we have here is SSL G static. Is that a reset? Yeah, that's a reset right there. So that's a kill. It's basically looks like all these are my computer to the other side. So I'm done talking to you. So decent amount of resets. So tcp.flags.reset double equals 1. All right, so that is chapter 20, TCP. Very, very important chapter. You're going to probably get tons of questions regarding TCP, sequence numbers, that type of stuff. Oh, also, if you want to see what connections you currently have, hopefully all of you know this, but there is a netstat-a, and you could do that from the command line. It's Windows, netstat space -a we'll give you your connections, and there's a lot of them. That's all right. Lots of connections. That's all of them. Very useful if you think you might be infected with the Trojan horse or something. You do a netstat-a and you see like a whole crap load of stuff. You might be might give you a jumping off point to start looking for stuff. Okay, let's close that out. Analyzing DHCP, that's going to be chapter 22. DORA. DORA is the most important acronym when you talk about DHCP. It stands for Discovery, Offer, Request, Acknowledgement. So how many of you guys in the room right now have heard the acronym DORA? It should be a CCNA, ICND, ICND1, I think. Might be ICND2, but should be something that you learn very early. And it is a favorite job interview question for me to ask people. It's like, oh, tell me about DHCP. So to look at DHCP, the unfortunate thing is we can't do this live, because if we do a DHCP, if we do an IP config release renew on your computer right now, while you're on this video chat, it's going to drop that out. Your connection is going to end. It's going to be a bad day for you. So that's why I had you guys download that file, because it has a DHCP discovery, offer, and request and acknowledgement from my computer while I was on the wired network right here. And we're going to be looking through that. So before we actually look at that, some common DHCP problems that we can talk about is one common problem: not enough DHCP addresses. You assigned a /24, and now you have 300 people in the office, and things are bombing out. Well, not enough DHCP addresses. That's a common one. Here we've run into that problem before. Even with a /23, so /23, 510, 512. There are times in this location where we have close to 1,000 people on wireless. So I think our record, not 1,000, but 850 people on wireless is our record here. Second problem is DHCP server giving out the wrong settings. You're getting DHCP, but it's spewing out the wrong settings. Wrong gateway, wrong subnet, wrong network, that type of stuff. Another problem is you can't reach the DHCP server. Might not be on the same VLAN, stuff like that. Could be the DHCP server is not even set up. So that's the Windows guy. Oh, I promise I configured DHCP. No, really, I did. And then the last one, which is the evil one, multiple DHCP servers. This is the one where someone they're studying for MCSE, Network Plus, whatever. They try to be smart and they bring a Linksys router to work and they plug it in. Yeah, and then it's got DHCP, your Windows server has DHCP, and mass havoc ensues. Okay, so those are some common problems you may have. So DORA: discovery, offer, request, acknowledgement. Now let's take a look at that file that I sent you guys. So file open, and you can continue without saving. And this is DHCP1, and you'll have to nuke your filter there. Now you can see this this packet capture is very, very clean. It's 18 packets and it's all DHCP. And the reason for this is when I did the capture, when I did, when I went to capture and options, down here for a capture filter, I put in port, I think it was port 67 or 68. So just give me the stuff for DHCP, and it filtered everything else out. And that's why this this packet capture file is very clean. It's just with DHCP stuff, because I didn't want the UDP in the video and all that other crap that goes along with any packet capture. So let's take a look at what happened. What happened here is I started the Wireshark capture before the Ethernet cable was plugged in. So Ethernet cable was out, had the capture going, I plugged it in. As soon as I plugged it in, like immediately, this is packet number 1. So let's take a look. You'll see that the source is all zeros going to 255, 255. So it's broadcast. Actually, all of this is a broadcast. Right? If you look down, it's all broadcast. All right, so if you go down here, it says bootstrap protocol, boot P. Expand that out. Message type, it is a request. And everything is 0. So basically it says, hey guys, I'm this MAC address. And you're saying, give me an IP address. Someone out there give me an IP address. I don't have one. And here's my MAC address. See, so that's the request right there. All right, let's take a look at 60.1 is my DHCP server. Where to get the PCAP? Didn't I paste it in the chat window? All right, I'll paste it again. Yeah, it was that mega link. Yep, Sheldon pasted it in there. Okay, I'll give you a couple seconds to catch up on that one. Okay, so packet number 1, we see source all zeros going to destination. Packet number 2, that's a reply coming back. Let's see what we got here. And you can see client MAC address 50, all that good stuff. That's the same MAC address that we sent out. So it's basically the other guy saying, okay, I see that you are requesting something. Just hold on for a second. Right. So kind of think of it as ICU. Right. This is a boot reply. And then you get it. You got the discovery, the DORA here. D. Okay. MAC address, that's your MAC address. Packet number 4. Offer. So we're on D and then O. So these two things up here, don't worry about packets 1 and 2. Start at 3 and then 4. So 4 is the offer. Let's take a look here. I am offering you 60.103. Right there. This is the stuff I'm offering you. I'm offering you 60.103. We got some other crap here. We have a relay agent 60.1. And it's got the MAC address in there just to make sure that I'm sending it to the right person. That's some other options here. Ooh, look at that. If you expand out the options, yeah, let's expand out all of these suckers. You'll see that we have a section for subnet mask /23. We have some lease times, server identifier, that's a Windows server, domain name, pandarg.com, the router is the gateway, and DNS. We got 2 of these guys, 2.2 and 2.3. So these are all information that we're going to be using to get out. And then packet number 5, that's us going back out. So discover, offer, request. The request here is, oh, that's pretty good. I'd like to use that. So I would like to request to use those IP addresses. And then finally the ACK. So discovery, offer, request, acknowledgement. And the ACK basically says, it's yours. Take it. Right. Now, if you want to filter just by like the D or the discovery or the offer, what you can do is you can make a filter. We're going to cheat here. Let's say you just want to see the acknowledgements here for DHCP. You can click down here and make a filter for it. So right click, apply as filter, and selected. So boot p.option.dhcp double equals 5. Right. So that looks like just the acknowledgements. Now you see that there's a lot of these here. And the reason you're seeing these is while I was doing the capture, there are other computers out there that might be looking at this. This could also be, let me see here. Let's take a look. Yeah, so that was 60.58, so that's another computer. This was 60.254. This guy right here was 60 dot something. Different computer. Okay, that's me. The 60.103 is me. And what's this guy? Client MAC address. That's someone different. 60.92, right? So all these other ones, these 4 other guys, were computers at the same time also getting DHCP IP addresses. Let's take a look at if we change this filter from double equals 5 to double equals 1. This is going to be all the ones for discover. So the D. Change that to 2. That's the offer. Let's see if 3 gets us anything. 3 is the request. So 1, 2, 3, and 5. Let's see what the 4 does. 4 is nothing. So 1, 2, 3, and 5. I could almost see that as a trick question. Why doesn't double equals 4 work? Okay, going back to our hackpad. Let's see here. We got the filtering boot p option .dhcp. So I put the filter in there, so that's good. So how would you troubleshoot this? Well, if the question is, can the DHCP server, are we actually getting anything from the DHCP server? First question you should probably ask yourself is anyone on the network able to connect to the internet? Right? If no one is able to connect, yeah, that could be a good candidate for DHCP server. If only your computer isn't able to connect and everyone, 200 others are, very unlikely that the DHCP server itself has a problem, but you never know. Maybe you're on a weird VLAN or whatever. You would first look for boot p option DHCP double equals 2. So you got a discover, an offer. Your computer is always going to do the discover. No problem there. But the 2 is looking for offers. It's filtering out the stuff coming from the DHCP server. If you're running this filter and you see absolutely nothing, even if you have computers, hook up a second computer to the network and do a ipconfig release renew. If you don't see anything with DHCP flag equals 2, then that DHCP server has a problem communicating back on the VLAN. Option 4, DHCP decline. Yeah, you don't usually see that too much. Decline says, I don't want that. Okay, that's a good question. Paul has a good question. Is the D broadcast and ORA is everything else unicast? Well, let's look. Let's take a look. So if we look at this, you'll see that everything is going to the destination of what? Whoa. All of the DHCP goes where? So 255, 255, 255, that's a broadcast. So Sheldon has something, DHCP offer can be sent as unicast. So what happens here is you could have something set up where you need to relay something over. So let's say your computer over here. You've got a computer, it needs an IP address, it's connected to a switch. And let's say the switch itself isn't actually given DHCP, it's someone else. So you have to go shoot out another VLAN, and there's an ugly Windows server over here. So in this case, you do a relay, and you could set that up to be a unicast if you want, because you're shooting directly to an IP address. But yeah, as you go through these, if you go through every one of these, you'll see that the destination under Ethernet, it's all Fs. And of course, IP address, all 255s. So the reason is remember the client hasn't actually accepted the IP yet. So the server is still basically saying, okay, we're still just talking to a MAC address out there. So this is actually a very important point to remember. Everyone hears this. It's a broadcast. Everyone hears it. The way your computer knows how to respond to it is when it looks into the sections here and it sees its MAC address. Stuff like this. Whoa. It's got to actually look inside the boot P packet. Okay, so Jeff says if the server's not local, it will use the helper address in the router. That's if you have it set up, and that will be a unicast address. Yes, that's not done by the client. The router is going to shoot that out unicast for you. So actually, ooh, this is probably dangerous. Hold on for a second. I can show you live. I think we should be good. One second here. Ah, crap, I don't have that router. Oh, can't show you. I was going to log into our main router here and show you the helper address and how that works, but right. So destination broadcast. All right, let's see what else we need to do here. Analyze DHCP. We cover discovery, offer, request acknowledgement. Common networking question during a technical interview. Many horror stories of CCIE or CCNP not knowing what DORA was, or not knowing the DHCP steps. That's basic right there. And we talked about the common DHCP problems. We talked about filtering of DHCP. Filtering of DHCP is some people mess up on because it's boot P and then DHCP. Better to just filter initially by boot P and then expand out the flags and then go down here to like do one of these flags, or go down here to message type request, and if we right click that, apply as filter and selected, you get the boot P type, and then you could filter it that way. Boot P type 2, boot P type 2 is good. Negative acknowledgement, NAC. All right, erase all that. So you can play around with this capture file a little bit, look through it a bit, and should help you out. And as always, when you're playing around with Wireshark, use a second computer, do Wireshark on one computer, connect another computer to the same switch, do ipconfig release renew, and look at what you can see. And you'll definitely see everything because it's a broadcast. It's going out to everyone. Okay, Ramesh has a question. Maybe change the lease time to 1 minute and see if it is a unicast broadcast during a renewal. I think it's a good chance you could set it for unicast, because remember, if it's coming up for renewal, you already have an IP address. Right? So your router and your DHCP server and your computer, you all have IP addresses now, and you don't need to broadcast out. It would be a good test, but that would be kind of dangerous for me to set lease times to 1 minute, assuming you can even do that. Well, let's see here. Can I set a lease time of 1 minute? Let's take a look here. Minimum DHCP lease time. And that's a Microsoft one. Yeah, it would be Microsoft because that's what our server is. Hell, no, I'm not going to do that. All right, so we can find that later. Yeah, yeah, it would make sense that it would be unicast. And then you do like it has a whole bunch of times where it tries to renew and renew and renew. And I don't remember exactly, but possibly one of the last, if it keeps dying on the unicast renewals, it might default back to broadcast, but don't quote me on that. All right, guys, so that was chapter 20, TCP, important points, handshake, and understanding the sequence numbers. We looked at DHCP, understanding DORA, learning how to filter out the flags, learning that everything is broadcast. So that's good stuff. Tomorrow we'll do the graphing, so IO graph and the other graphs. We're in the kind of the final stages, so you have a lot of 1Z, 2Z type stuff. So we've covered the bulk of everything, all the hard stuff really up until now. And now it's basically like, okay, this menu does this and that menu does that.